Hi guys, it's Virginia. I'm going to do an example on using the law of cosines to solve side angle side type problems. So these go along with the types of homework problems that you would see corresponding to section 4.2 in the textbooks, the pre-calculus textbook for Math 1151. Or you might see problems like this if you're in Math 1269 and Homework 5. So I'm given side length C, side length A, and one angle, angle B. So the first thing I'm going to do is just check out my formula I like to look at the slideshows to see, just quickly at a glance, get a formula reference. So since we know angle B, we know A, we know C, we can use this particular version of the formula to solve for B, which is unknown. So that's the approach we're going to start to take to tackle this problem. So I'm going to go over to my demo calculations here. Find side length B using the law of cosines. Just going to repeat the formula, the general formula, and then plug in the known values that I know. And then I like to simplify everything as much as possible first before I start actually getting a decimal value. So like taking the cosine, taking the square root, something like that, that's going to create an approximate value. I like to just make sure I have everything else as simplified as possible. So I'm going to go ahead and plug this into the calculator now. And I opened up Desmo's scientific calculator. It's a really nice online one to use, or you could use your graphing calculator. And so it was 85. Oh wait, I need to take the square root first. You can always use a button down here. 85 minus 84 cosine of 85 degrees. We're in degrees, and we get this value with all of these decimal digits. So at this point, our value is now approximate. So I went ahead and here's that square rooting step. And then here's our approximate value we got from Desmos. Now, I like to immediately switch over to the approximate sign just to remind me that everything I'm going to do from here on out, I need to be true to the fact that this is an approximation and make sure I have as many digits as I need to keep accurate. So here's two things to remember. Read the problem to know how many decimal places you have to report. So let's go ahead and do that. In this problem, it says round lengths to the nearest hundredth of a unit. So we need to do 8.81. And I'm going to go ahead and get that in there. And let's think about the next step. So I now have a side angle pair, which is really nice because once you have a side angle pair and you know one other piece of information, you can use law of sines, which I think is a little bit easier to just crunch through the numbers than law of cosines. So I'm going to use this nice side angle pair that I have to solve for, you could pick A or C. I'm going to pick A, I think. So I am going to have to use this 8.81 in the calculations as I go on. So because 8.81 is rounded, it's going to throw off my calculations for angle A unless I continue to keep all of these decimal digits. And then it's going to be as accurate as it can be, or I can use the storing function and it'll store all of the information that's in the calculator's memory. So let's go ahead and do that, and I'll show you how I do that. So law of sines, I just copied it over. And again, if you can't remember the formula, you can always go back. And that formula is in here. It's in section 4.1, and just grab the transcript, the slideshow, and you have it all right there. So there's the general formula. And I'm going to simplify to solve for just try and get angle A by itself. But again, so I'm multiplying both sides by A. But to get A by itself at this point, I need to take the inverse sign of this entire quantity over on the right-hand side. And so you could You could type this in exactly as it's shown here, keeping all of these digits, but here is a better way, I think. So I'm going to go ahead and hit enter, and I need the inverse sine function, so you might have to glance around and try and find where that function is. So it is 6 times sine of 85, this is angle B, divided by, and then this previous calculation was our side length B. So let's just go ahead and copy that down on over. So now we didn't have to do all that typing. So again, here we have another approximate value. This time it's for angle A. And so let's see, what do we need to report this to? So angles are to the nearest 1/10 of a degree. Cool. So we just need to carry over 42.7. And I think this is just showing now A is approximately this. And I can go ahead and stick that value in the mat tool. All right, so the only remaining thing that we don't know is angle C. And of course, you could use law of sines again and use exactly the same process that we just did for A. But the easiest thing to do is just subtract. And, of course, now that we're using A, which is an approximation, we need to, in our calculations, carry all the decimal digits. Even though we reported A, which is 1, we want to bring them all along to make sure that we get angle C as accurate as possible as well. So I did this again in Desmos. I subtracted the answer out, and I subtracted 85, and then I get this approximate value here. So approximately 52.298, blah, 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 blah. So I only need to go to the 1/10 of the degree, so it's 52.3. And I'm ready to check my work, and we got it right. So just remember, read the problem statement to see how many digits you need to supply, and use your storing function if you can. It's a lifesaver. All right, thanks guys. I hope that helps. Bye.